Good morning, ma'am. My name is B. Ramu. I'm from third year in the Department of Electronics and Communication Engineering, B section. My name is B. Ramu. I'm from Institute of Aeronautical Engineering. So my topic is instrumentation measurements applications for educational purpose. An overview of techniques and learning tools. So introduction to the instrumentation and measurement. Instrumentation. The technology of measuring physical quantities like temperature, pressure, or flow, and etc. Measurements. The process of obtaining data about physical parameters in quantifiable manner. Importance. It's essential for experiments, engineering applications, and providing insights in various fields. We can see everything, it has some measurements, right? The role of instrumentation in educational purpose helps student understand theoretical concepts through hands-on experiment. uh, it means you gain some knowledge, right? So to use or implement in real time, so we need to know what are the measurements. So everything has some boundaries, right? To overcome that, what is the last one, what is the least one. So it's nothing but measurements, right? Teaches practical skills for data acquisitions, analysis, and instrumentation use. Enhance problem solving skills by applying theory to real world scenarios. And common instruments used in educational labs: multimeter, measuring voltage, current, and resistance; oscilloscope, visualize signal waveforms, crucial for electronics education. So this is most important. The oscilloscope is nothing but it displays the input and output signals, how the signal will flows. uh, Thermocouple and thermometer measure the temperature in physics and chemistry labs. Not only this, there are number of uh, measurements instruments are there. For example, Vernier calipers, it can useful in physics lab, and ammeter, voltmeter. Number of instruments are there. So measurements technique for educational purpose: direct measurement, indirect measurements, remote sensing. There are three types of measurements. Let me discuss one by one. The first one, direct measurements, measuring quantities directly, like using a ruler of length. It means uh, when we measure a length of bottle, so that we can use, or using scale we can directly measure, right? So this is comes under direct measurements. It means we can physically measure this. Indirect measurements, interfering quantities from related measurements like temperature for resistance. These are indirect. This is not touching physically. It means like we can't touch temperature, resistance, or conductor, air, any fuel, not fuels, any uh, like oxygen, nitrogen, etc., etc. Those are all called as a indirect measurements, because everything has some measurements, right? How we can measurements indirectly, so that we can call it as indirect measurements. And the last one, remote sensing, The remote sensing use sensor to collect the data in accessible areas, useful in environment science education. So the best example of this, drone. So by using drone, nowadays the land, forest area, uh, seas, rivers, these all the things are measured. It's not applicable for direct, indirect. So to reduce time complexity and uh, man complexity, we use remote sensing. This is also one type of indirect measurements. Digital versus analog instrumentation in education. So digital means uh, the logic 0 and logic 1, and analog means it can continuously in respect to the time. The analog instruments are traditional manual readings, help students learn fundamental principles, and digital instruments are precise and easy to read displays, often used in modern labs. The analog instruments is nothing but it is a traditional way, manual readings. For example, uh, oscilloscope. When we see the oscilloscope, the input and output waves are displayed. So the length and the frequency, length is called as amplitude, and what is the time period, and what is the frequency, and what is the t on t off, like etc. So everything has manually read it, right? So these are called it as analog instruments. And coming to digital instruments, precise and easy to read displays. So when we write the code, VLSI or VHDL code for decoder anything, so it displays some waveforms, right? It's having zeros and ones. So the measurements are precise and easy to read and display. So these are called as a digital instruments. So using these analog and digital, the benefits are both provided unique learning opportunities and reinforce accuracy. So analog is a fundamental to use without any help. It can measure using your eyes and hands. So digital also is very useful, so to precise and reduce the time complexity and some errors like parallax errors and environment errors, gram errors, etc. So data acquisition systems, DAQ, in educational labs. DAQ is nothing but systems that collects, process, and the stores data from sensors instrumentation. It's nothing but we have some sensor, it can collect or process, store the data from the sensor. It's called as a DAQ, and uses commonly used for experiments requiring continuous data monitoring. So when we when we want to perform any experiments, it's continuously requiring data, right? Educational benefits are teaches students about the data lagging and processing and analytic techniques, and the importance of calibration in educational systems. The calibration is nothing but it's a process addressing instrumentation to ensure accuracy. So it's nothing but we have any instruments. So to get the perfect output, we need to set some settings, right? So these settings, uh, predicting, it means we can fix some length or some radius. So these are call it as we can predict, right? So this is called as a calibration. So teaches students the importance of precision in scientific measurements, essential for experiments where high accuracy and repeatability are required. And the applications of instrumentation in various fields, physics, engineering, chemistry, and not only engineering, can also useful in biomedical, medical, all the fields. The measurements is more important. In physics lab, we can use motion, energy, electricity, velocity, and etc. In chemistry, we use temperature, pressure, movement, and reaction, and etc. Cool. In engineering instrumentation, for system analysis, control analysis, robotics, and pulse, and microprocessor controllers, etc. A lot of things are there to every experiment or every application. We need to know the measurements of it. And I conclude that instrumentation measurements is a fundamental to understand the applying scientific principles. Educational applications help students to develop practical skills in measurements and analysis. So, instrumentation in educational, it bridges theory and practice, preparing students for various scientific fields. Thank you.